שלום, אני מהטכניון והמעבדה שלנו נקראת המעבדה ל-Virtual Reality and Neurocognition ואלה הם הסטודנטים שלי וכל מה שאני אגיד היום נעשה יחד עם הסטודנטים שלי ותודה רבה שהזמנתם אותי. אז היום אני גיליתי שאפשר לדבר פה בעברית, לא ידעתי, חשבתי שצריך לדבר באנגלית, אז הכל הוא חד באנגלית ואני אדבר באנגלית אבל פה ושם אני ארבב בעברית. So we have a virtual reality and what we do is we put people in a virtual reality and we ask them to solve all kinds of problems and perform all kinds of tasks. And at the same time we connect them to EEG. So we collect information about the activity of the brain, different types of activity. And then we use the information about how much was learned, about the sensory cues in the virtual reality and the activations in the brain in order to create a model of optimal learning. So these are some of the technologies we have in the lab. You're invited. So what am I going to talk about? I'm going to talk a little bit, just building blocks, just really a few words about virtual reality and augmented reality. Then I'm going to talk a little bit about the social brain in virtual or augmented reality, because I think that virtual or augmented reality has a major role in social interaction, especially in the case of learning, because you have social learning with a teacher or with peers, and the question is how do we create this kind of learning? Then I'm going to argue that the level of experience in virtual reality or augmented reality is not determined, as many people think, by the technology itself, by the level of technology. But I can create different types of illusions to create in a virtual environment experience which is much stronger than the experience in the physical reality. And I'll try to convince you on that, and then I'll try to show you how I use that in order to consolidate memory, in order to improve the processing time and make it shorter, and so on. So what is virtual reality? Virtual reality can be the subjective sensory experience of being immersed in something which is mediated, created by the computer. We all know that, so I'm not going to spend time on it. And then in creating virtual worlds, we'll design the sensory experiences. It's we who develop the virtual world who plan what is going to be experienced. We orchestrate the sensory stimuli to create a virtual taste, sight, smell, sound, or touch. The technology of experiencing VR, we have special gloves, we have earphones, we have goggles, by the day, we have new technologies. And what you feel is you can touch the water as if you really and feel the coldness. We have new sensors, new effectors that we can put on the fingers, and you feel as if you put your hand inside the water. It gives you a feeling of wet, and so on. You can juggle with different kind of imaginary balls. You can feel fields. There are new types of haptic touch interfaces which evolve by the day. And this is the Oculus that you saw before. And this, just below, you can see a device which they just published in Kickstarter, and they are trying to get money for this. So what this is trying to do is you have a smell producer. At this point, you have a smell producer. At this point, you have hot air, so you feel like a wind. And this side, you feel steam, and this is the loudspeaker, and so on. So suppose that this is what you see, and then you can feel the wind of the hot wind, and you can smell the burn, and so on. So this is what virtual reality offers, hopefully soon. Now, we started, this has been developed by Mel Slater something like 8 years ago in the cave in London. We can do it now without the cave. And this was the kind of virtual reality that we're able to do. We have much better virtual reality, and we can move to examples which I'm going to bring in a few minutes. So augmented reality, you saw some of the pictures, you know what it means. So you have overlaid virtual on physical. So reality as you feel it is augmented. let's talk a little bit about the social virtual reality. Last year I spent my sabbatical at Stanford, and part of the time I went to Singapore to IMI, Institute for Media Innovation at NTU, Nanyang Technological University. Nadia Talaman, Professor Nadia Talaman, was the head of the institute, and she ordered a robot. And the name of the robot is Nadine, and this is the robot. She's wearing glasses. And the robot had so many, she had enough engines to move the face in a way that was very similar to a human, but not exactly. And each time you look at the robot, at Nadine, it looked creepy. It looked weird. It looked as something that you cannot accept. You don't know how to take this. This is called the Uncanny Valley. So in a virtual world, when you have something which is very similar to a human, but not exactly, you get into this kind of uncanny valley. Why is it important to interact? I don't know about MOOCs, but why is it important when you learn, when you teach, why it's important to interact face-to-face? The reason why it's important is because only 10% of the information is conveyed through words. Everything else, and some people say even less. So Nalini Ambati from Stanford, she claims that only 3% is conveyed. So how is everything else perceived? Turns out that we perceive, even under, without being aware of it, and some of the cues that we perceive are under the threshold of perception, what we call sometimes subliminal. So it's very difficult to create this kind of human-human interaction with an avatar or robot that doesn't look exactly like a human. So what we did, this is Bracha. Bracha, she was one of my students at that time. She just gave birth, she's at home, she doesn't want to come to the lab, but she has to talk to Amit. And she wants to teach Amit exactly how to take blood pressure. So she has a device at home, and she shows him how to take blood pressure. What we did is we created a 3D model of Bracha. We sent it over the web and reconstructed Bracha in the lab. So you can see Bracha here being projected, being seen in 3 dimensions, coming out of a huge screen in real size. I could make her, of course, 5 meters high too, but she didn't let me to do that. So this is Bracha. I also inserted a heart, but I could actually insert a realistic simulation, or not even simulation, but a realistic dynamics video of how the heart works in 3 dimensions. If I had the ultrasound, because I can take the ultrasound and translate it into 3D simulation of a heart. And this is Amit, and they talk to each other as if face to face. So let's go for education. So Bracha is a teacher. I can create now interaction, human-human interaction, without the distances. I can overcome the distances. So I think that VR can help us also understand learning, have a better insight into what learning is. And now I'm going to ask, is there also potential in order to enhance learning? And I'm going to show you 2 examples if I have the time, and if I don't, I don't. And there are obvious applications for education. So you can be inside the multisensory world, like navigating inside an electromagnetic field in physics. My background is in physics, so most of my examples will be in physics. You can look at interacting molecules and be part of the interacting molecules if you want to. You can interact with people that lived in Jerusalem 2,000 years ago, or you can discuss science with Einstein if this is what you get your fun from. So I'm going to bring a few examples of enhancement. How am I with time? Okay. זה מכוסה, אי אפשר לראות. בסדר. So this is a virtual world, and this is Liat. And Liat has a cap with EEG electrodes. So I'm able to pick up the electrical activity of the brain while she plays a game. And in this case, what she had to do was something very simple. She had 2 tracks, and she had to move between the 2 tracks. And our virtual world is such that you also feel that you touch the tracks. So there is haptic, there is a sense of feeling. I'm not going to get into details how, but again, you are invited. So what we did, we wanted to find out what are the conditions under which the speed of processing would be highest, so that people will process information fast. And I want to find out what do I need to do in order to create these conditions. So we told her, you have to stop and press a button each time you hear a sound, you see a light, or you feel a small touch on your hand. See a light, of course, in the virtual world, hear a sound in the virtual world, or a touch. And what do you think? What would be the fastest? To what kind of cue would our response be the fastest? How many think it is light? How many people think it is auditory cues, sound? Okay, and how many people think that it is the touch? And there are many people who don't think too. So help me, look at this. When it was only a visual cue, it was a light coming up. It was about 400 milliseconds that it took, on average, to 82 subjects to respond, and they had to repeat that for about 900 times. So it's high validity. So it's about 400 milliseconds. 400 milliseconds on average when you see a light. When you go to haptics, it's less, it's about only 325, and even less when you go to auditory, but the difference is not significant. But look at what's happening when I put all 3 together, auditory, visual, and haptic. It goes down to a little bit above 200. So I was able to reduce the processing, the brain processing time by about 45%. What does it mean for learning? We have to find out, but that means that there are situations in which we are able to enhance processing, make it more efficient, at least time-wise. Now we know in education that multisensory, multimodal representations actually improve learning. This is one of the things that we can show. This is something which is really interesting. I wanted to show here how we consolidate memory. So you just heard a little bit about neurofeedback. Neurofeedback is a situation in which I have electrodes that measure my brain waves. In this case, it was theta and beta. Theta is 4 to 8 hertz, some say 7, let's say 4 to 8 hertz. And I wanted to find out what happens to consolidation of memory. So most of you know that if you learn something in the morning, let's say you learn a new piece of Chopin in the morning, you have never played that before. And this is the first time. And you play until you are so good that you cannot become any better. And then you leave it. And I test you right afterwards. And then I test you again in the evening, after 8 hours, let's say. And then I test you again after 24 hours. And again after 36, again after 48. Why would you be best? After how, at what point in time? Immediately after? How many people think immediately after? Well, the story is that it is after you sleep. Because during sleep, there is an interesting process of memory consolidation. And my question in this study was, will I be able to create memory consolidation without sleep? So if you look at papers about memory consolidation, what you find is that theta has a major role in the process of memory consolidation. It's a beautiful process. I wish I had time to go into it, but again, you can find more about this. So it's a very beautiful process, and theta has a major role in it, in which 2 distinct areas oscillate with the frequency of theta, 4 to 8 hertz. And I want to find out if I will be able to create a situation in which a person can control their brain waves so that they oscillate 4 to 8 in the right areas, of course, then maybe I can create consolidation of memory immediately after. And this is what I did. So I used neurofeedback. And neurofeedback, I put the electrodes on the scalp, and I measure the brain waves, and then I provide feedback. And in our case, the feedback was racing cars. So I asked people, make your car travel faster, and only if theta goes up, the car will indeed travel faster. Normally, it takes not more than 3 minutes. I even ran it on an 80-year-old lady, and it took her less than 3 minutes. So it's doable, it's learnable, and it's fast learnable. Now that people were able to increase theta, what I did the following experiment. I taught them something which is similar to playing piano. I had 3 groups. One was theta, the other one beta, the third was control. I took beta just to see that it wasn't only the neurofeedback which creates that. I tested them before. The 3 groups were the same. I tested them immediately after they finished learning. The 3 groups were the same, but look at what happened after neurofeedback. You can see that the blue group and the purple and yellow group, there is a distance between them, which increases after night sleep, further increases after more night sleep, further and further until 7 days. So memory consolidation was obvious. How this relates to education, I think it's almost obvious, because memory is a major issue in learning. But beyond that, we can create these kind of small applications that people will be able to play a game and consolidate memory. So I don't think I can talk about that, but we also know how to look at errors. And you know the feeling that you talk, and while you talk, you know you shouldn't have said that, and you would like to stop and not say that, but it's too late. This is the error potential. It turns out that there is a distinct error potential, a distinct brain potential, which I can measure, which happens even before you actually perform that mistake, that error. We can use that also in education. I think that I don't have enough time to say additional stuff, and I want just to summarize that the advantage of VR is not just in creating worlds that do not exist. It's much beyond. The first time that we have a way to orchestrate stimuli in order to enhance learning. Thanks.